Hi everyone, let's work on 3.2 homework, which is going over graphs of functions. I'm going to start with question number 2. So a graph of a function is given here, and we want to find f of -7 and f of -2. We know that -7 is the x value of the function, and f of -7 is looking basically for the y value of the function when x is equal to -7. So on the x-axis, I'm going to look for x equal to -7, which is this point, and I see that the y value for that x is equal to -2. F of -2 is right here. F of 6 is 2, and f of 0 is -1. Is f of 2 positive or negative? F of 2 is a negative value. It's -2. Let's look at part E. It's asking us for what values of x is f of x equal to 0. So basically, it's just asking for the points of the function that y value at those points is equal to 0. Those are this one, and this one. X of this one is -6, this one is -1, and this one is 4. So those are the answers. For what values of x, f of x is greater than 0. So f of x is greater than 0 wherever the graph is above the x-axis. So that is this part and this part. In order to find the x values, that for those x values, f of x is greater than 0, I'm going to start with this point, which is the start point of this part of the graph. So starts from -6, and this part ends at -1. So you're going to write x of a start and x of end. So x is between these two values. I'm not going to put equal sign because right at x equal to -6, the value of the function is 0. It's not greater than 0. And the same for this one. The second part starts from 4 and ends at 6. So x is between these two values. Again, for 4, I don't put equal sign, but for 6, I will, because at x equal to 6, the y value is equal to 2. Now let's look for the domain of the function. Domain is all the x values, set of all x values, which are covered by the function. So from left to the right, I'm going to move and find the x values that are covered. The first x value that is covered is this one, which is at -7. And there's no limit between these points. The last point which is covered is x equal to 6. So x is between these values. However, I'm going to put equal sign here because the point -7 itself is part of the graph. It's covered. I have closed circle at this point. So those are parts of the graph. Okay, now let's find the domain and range of this function. In order to find the domain, I move from left to the right and look for the x values that are covered by a function. So from the left side, I see an arrow. So that means it's starting from -infinity. And as I move to the right side, there's no limits here. The function is going to +infinity because I see another arrow here. So this is the domain. And the range, I move bottom to the top and look for the y values that are covered by the function. Because as I move from bottom to the top, I see arrows here. That means the function is starting from -infinity. And the last point that I see as I move from bottom to top is this part. The y value of this part is 3. So that's the end of my range. -infinity always takes negative parentheses, and 3 is taking bracket here because the 3 itself is covered by the function. The intercepts of the function. X-intercept is where the graph is crossing the x-axis. That's these 2 points, which are -2 and 2. Y-intercept is the graph where the graph is crossing the y-axis. and that's here at 3. Is any symmetry with respect to x-axis, y-axis, or origin here? Yes, I can see symmetry to the y-axis because any point on the left side of the y-axis has a mirror on the right side. So yes, there is a symmetry to the y-axis. Question number 4 is giving this function to us and it's asking, is the point -2 and 9 on the graph of f? So I just need to try that when x is equal to -2, what is f of -2? That's 2 times -2 squared minus -2 minus 1. So wherever you see x, plug that with -2. So that's going to be -2 squared is 4 times 2, 8, minus -2 is plus 2 minus 1. So that's equal to 9. So yes, because f of -2 is equal to 9. When x equal to 2, what is f of x? Just plug in x equal to 2 to the function and find the value. So this is going to be 8 minus 3 minus 1, which will be, minus 2 minus 1, which will be 5. Now, if f of x equal to -1, what is the value of x? In this case, the y value is -1, and we're looking for x. So this time, I'm gonna set f of x equal to -1, which is this 2x squared minus x minus 1 is equal to -1. Now I'm going to solve this for x. So the -1 cancel. So I will have 2x squared minus x equal to 0. Now in order to solve, I can factor the x out because that's the common term that both of these two are divisible. This divided by x is 2x. This one divided by x is -1. Now your function has two factors and it's equal to 0. To solve for x, I'm going to set each factor equal to 0. One of them is x, the other one is 2x minus 1. Okay, the first one already gives me the solution. And the second one, if I solve, add 1, and then 2x is equal to 1. And from here, x is equal to 1 over 2. So these are the two answers. When f of x equal to -1, x could be 0 or could be 1/2. Now, what is the domain of f? We know that this is a quadratic function, and quadratic functions always look like this way, a parabola, or this way. And this is going to be this case, the one that looks upward. Anyway, for any quadratic function, we know that the domain is always -infinity to infinity because there's no fraction or any radical to limit my domain. There's no limits here. Next question is asking us to find the domain, list the x-intercepts of the function. So how do I find the x-intercept? X-intercept is where the y value equal to 0. So I'm going to set this equal to 0, 2x squared minus x minus 1 equal to 0, and solve for x. So I'm going to look for two numbers that if I add them, I get -1. If I multiply, I get 2 times -1, which is -1. So this is, -2. This is the b value, which is this one. And this one is a times c. That's the coefficient of x squared times the constant value. So the two numbers could be -2 and 1. Now, in order to factor, I'm going to keep the first term by itself. Because the a value is not 1, I'm going to change it to 4 terms and then factor by grouping. The middle term is going to be split by these two values, -2x plus 1x. And I have a -1 here. Now, I'm going to put them in two different groups. The first group has 2x in common between them, so 2x. This divided by 2x is x. This divided by 2x is -1, so I factored 2x. And the next one, I can factor 1 out. This divided by 1 is itself. This one divided by 1 is also itself. So now I see that x minus 1 is in common between them. So I'm going to factor x minus 1 from both groups. X minus 1 here. If I factor x minus 1 from this first group, only 2x will be left. The second group, only 1 will be left if I factor x minus 1. Now I can solve. I'm going to have two answers. Set each factor equal to 0. So from here, x equal to 1. And the next one, x will be equal to -1/2. So these are the two x-intercepts. To find the y-intercept, you need to set the x equal to 0. So on this function, wherever I see x, I'm going to plug 0 for that. So 2 times 0 squared minus 0 minus 1. These two are 0, so y is equal to -1. So y-intercept is 0 and -1, and x-intercept is 1 and 0, and -1/2 and 0. Question number 5 is asking us to find f plus g of 3 if the f is given here by this red graph and g of x is given by this blue graph. So in order to find f plus g of 3, I need to find f of 3 and add it by g of 3. What is f of 3? When x is 3, f is 3. And then g of 3 is -5. So this is just 3 plus -5, which is -2. And if minus g of 5, this is f of 5 minus g of 5. Okay, f of 5 is -1. G of 5 is also -1 because they're crossing at the same point. So this will be 1 plus 1, -1 plus 1, which is equal to 0. Now, what is g minus f of 5? So g of 5 minus f of 5. G of 5 is -1. F of 5 is also -1. So this is -1 minus -1, which is 0. Next one is f of g, f times g of 1. So for this one, you're going to find f of 1 and find g of 1 and multiply them by each other. Okay, what is f of 1? It's 7. What is g of 1? That's -1. So this times -1 gives me -7. Then f divided by g of 3. So you're going to find f of 3 and divide by g of 3. F of 3 is 3. G of 3 is -5. So that's my answer. Question number 6. If a basketball player shoots a foul shot, releasing the ball at a 45-degree angle from a position 6 feet above the floor, then the path of the ball can be modeled by its function, where h is the height of the ball and x is the forward distance of the ball in front of the foul line, and v is the initial velocity. Now we're going to answer these questions about this situation. It says find the height of the ball after it has traveled 7 feet in front of the foul line. So this 7 is basically our x value. And all we need to do is plug in the x into this function and find h, which is the height of the ball. So I need to find what is h of 7 for this function, -44 times 7 squared over the v is given as 26. 26 squared plus x again, which is 7 plus 6. And we can use our calculator to find this value. The next one is also the same. It's asking us to find the height when the ball has traveled 13 feet. So this time x is 13, and you're going to find h of 13 the same way, just plug in the value. Part C of the question is asking us to find additional points and find the graph of the function. For this one, you can easily use your calculator. So on my calculator, I go to y equal and then enter this function and then just graph the function. And I see that it looks like this one. Make sure you have the proper window, which is, in this case, I made it negative 10 to 50 for x and negative 10 to 10 for the y value. Part D of the question is asking us if the center of the hoop is located 10 feet above the floor and 15 feet in the front of the foul line, will the ball go through the hoop? So this time here, I know this 15 is basically my x value, and 10, because it's talking about the height basically, 10 feet above the floor, so this is the y value. This is x, this is y. So I just need to know if the graph of the function is passing through this point, 15 and 10 or not. If it does, that means if this point is part of the graph, then that means the ball will go through the hoop. If not, it's not. So let's try and see. I'm going to find f of 15 and see if it's equal to 10 or not. So just plug in 15 for x here, negative 44x squared over 26 squared plus x plus 6. And wherever I have x, I'm going to replace that with 15. So here I will have times 15 squared and a 15 here. When you calculate all this, it's going to be equal to 6.35. So as you see, when x is 15, y is not 10, it's 6.35. That means the ball is not going to pass through the hoop. Then it's asking us, if not, with what initial velocity must the ball be shot in order for the ball to go through the hoop? So this time, we want to know what should be the velocity in order to the function pass through this point 15 and 10. So I'm going to first of all plug in 15 and 10 here. So that means h of 15, which is equal to 10, is 44, 15 squared over v squared plus x is 15. I'm going to plug that here and 6 here. So I plugged in 15 and 10 into my function, and this time I'm looking for v. I want to know what should be the velocity in order to the function pass through this point. So I'm going to look for the v value and solve for it. Okay, so let's just simplify. The left side is 10. 15 plus 6 is 21. So I'm going to subtract 21 from both sides. So 10 minus 21 will be negative 11 on the left side, equal to negative 44 times 15 squared over v squared. Now, in order to solve, I'm going to put the denominator of 1 and cross multiple. So negative 11v squared, negative 11v squared is equal to negative 44 times 15 squared. Now, in order to find the v squared, you divide both sides by negative 11, and v squared will be negative 44 times 15 squared divided by negative 11. And then, since the negatives are going to cancel each other, I'm going to cross them. And now, in order to find the v, just take the square root of both sides. And when you take a square root, this will be equal to 30. So the initial velocity should be 30 for the function to pass through these two, this point. Question number 7. A golf ball is hit with an initial velocity of 150 feet per second at an inclination of 45 degrees to the horizontal. In physics, it is established that the height h of the golf ball is given by this function, where x is the horizontal distance that the golf ball has traveled. Now, let's answer some questions about this situation. Part C is asking us what is h of 400. So simply your x is 400, you plug in 400 into this function, and you're going to find h of 400 equal to this value. In order to interpret the value of h of 400, that means the height of the golf ball after it has traveled horizontal distance of 400 is this many feet. Part D is asking us how far was the golf ball hit. That means when you throw the ball, basically hit the ball from here, it's gonna, you know that it's gonna have a projectile motion, so it goes up and then comes back to the earth. So this is the first part that the first point that the ball is on the ground, basically. When you throw it up, it's gonna go there and then it's gonna hit the ground here as well. So we want to know what is the x value when the ball hit, basically when it goes here to this point. So basically we know that at this point the height is equal to 0. So this is the y value. In order to find what is the x when height is equal to 0, I'm just going to set this equation equal to 0. So this equal to 0 and then look for x. So solve this for x. In order to solve this for x, I see that I have one term which is this negative 32 over 150 squared times x squared plus x. So two terms. They both are divisible by x. So the first thing that I'm going to do, factor x out. So I will have negative 32x, because one of the x's is here now, over 150 squared plus 1. This divided by x when the x is factored out will be equal to 1. Now you have two factors. One of them is x. It's equal to 0. This is the initial point where at the first point the ball was hit, basically. And the second one is this factor. So I'm going to set this equal to 0, and negative 32x over 150 squared plus 1 equal to 0. So I subtract 1 from both sides. Now I will have negative 32x over 150 squared equal to negative 1. The negatives cancel each other. So I'm just going to erase them. Now put a denominator of 1 and then cross multiply. So 32x is equal to 150 squared. So this times 1 and this times 1. Now x will be 150 squared over 32, and then you can use your calculator to find the exact value. Now it's asking to use a graphing utility to graph this function. So also it's mentioned here that you can use this window. Your x window should be from 0 to 800. The y should be from 0 to 180. X scale is 100 and y scale is 2. So I'm using my calculator. At y equal to 2, I enter the function. The window is defined here. I press window. X min is 0 to 800. This is what the question already gave me. Y min is 0 and Y max is 100. The X scale is 100, Y scale is 200. So you can just change all these and then graph the function, and you see that this is what the graph is looking like. And we see that this one is the right answer. Next is asking us to use the graphing utility to determine the distance that the ball has traveled when the height of the ball is 100 feet. So we know that the ball is going this way. Okay, on my coordinate plane, it's going to look something like this. And when it says the height is 100, that means on the y axis, I am going to find a point which is 100, and then Wherever the graph is crossing this 100, this is where the height of the ball 100. So I'm going to use this idea. On my calculator, I'm going to define a second function here, and that is y equal to 100. Now, if you graph the function, you see that there is a horizontal line. This is where the y equal to 100. Now, to find the x value for these two, I go second, trace, and number 5, which is intersect. Now it's asking, what is your first curve? Just press enter, automatically goes to first curve, and then second curve automatically goes there, so enter. And then it's asking, what is your guess? So just move your cursor close to the point that is the intersect of these two lines. Doesn't have to be on top, close is enough. And here I press enter, it's going to give me this point, 120.7299. To find the next one, do the same thing. 5, enter, enter, and move the cursor close to that point. Even here is okay, and enter. It will go to the point, and that's the other point. So these are the values of the x when the height is 100. Next part is asking us to create a table with table start at 0, and the steps of the table is 25. With the nearest 25, we want to find the nearest what is the distance that the ball is traveling. So, and also it's asking us to find the maximum height. So for this question, this is what I'm going to do. I have the function at y equal to y1 equal to. I don't need the second one anymore. Now I'm going to find my table first. So when I go to second window here, it's going to give me the table set. I changed the table start from 0, and the step should be 25. I already have changed it, 25. Now I'm going to go to see the table. Second graph is going to give me the values on the table. Now I see here that is the list of x values. This is the list of y values. And as I move down, I'm going to check these values and see which one is the highest value, because it's asking us for the maximum height. So I need to see what is the highest value of y. And I'm going to check all these values. You can use your calculator again to find the exact value of these points, like 418 divided by 9, and check them all and see which one is the biggest one. And we see that the largest value is this. This is the largest value of y. So the x for this point is almost 350 for the nearest 25. And this is the y value, which is equal to 175.78. And the x is 350. Next is asking us to adjust the value of the steps of the table until you determine the distance within 1 foot that the ball travels before it reaches the maximum height. So on the previous part, we found to the nearest 25 feet. That means it wasn't very accurate. Now we want to be more accurate and find it within 1 foot. So what do I do here? I know that this was my graph, and let's say the maximum height that we found is here. We found that it was almost 350, but it's not really accurate. So I'm going to find the maximum with the smallest value of the steps of the table to find the exact value. So I'm going to make my table start from a point close to this point, and then take all the values of the table to find what is the highest value. So I'm going to go to my table, and I go second window to find the table set, and I'm going to start with let's say 345, because the maximum height that I found was 350. So I start from a little bit behind this one, and the table steps is 1 feet. Now when I go to second graph, I'm going to check all these values and see which one has the highest y value. Again, you may use your calculator to find the exact point and see which one is bigger until you will see that this 352 is the highest value. So that 352 is going to reach at the highest value. This is more accurate. Okay, next question, number 8. Let C be the function whose graph is given to the right. This graph represents the cost C of using any time cell phone minutes in a month for a 5% family plan. So what is C of 0? So we see that when x is 0, the y value of the function is 100. So that's equal to 100. And that means the value of C of 0 represents the monthly fee. That means even without using any minutes at the beginning, you have to pay a monthly fee of $100. So this is the cost per month if no minutes are used. Next one, C of 1,000. So on your graph, you're going to look when x is equal to 1,000, y is 100. So this is going to be the value of C of 1,000 represents a monthly charge if 1,000 minutes are used. Next is C of 4,000, and on the graph you can see the value of that, which is this number, and then that means the value of C of 4,000 represents a monthly charge if 4,000 minutes are used. The domain of the function, as you see on the x-axis, you see that it starts from 0 and ends at 1,4,500. So that's the domain of the function, and it means that at most 1,4,500 anytime minutes in a month is used basically. Next, describe the shape of the graph. The shape of the graph is flat at first. This is where it's flat, and then after that it's increasing at a constant rate after m equal to 1,000. So this is when m equal to 1,000. After this point, it's increasing by a constant rate. Next question. This graph represents the distance v that Kevin was from home as a function of time in hours. So we're going to answer some questions to see how many hours elapsed and how far was Kevin from home during this time. So the first one, for example, says from 2 equal to 0 to 2 equal to 3. Where is that? From 0 to 3. During this time, 3 hours elapsed. And then how far was Kevin from home during this time? From 0 to 10 miles. So the x is 0, y is also 0 here, and here x is 3, y is 10. So the y value is the distance, and it's from 0 to 10. From t equal to 3 to t equal to 3.3, the time is 0.3 hours. And what is happening here? The distance that he has from the home is 10 miles, because from at this point the distance is 10 miles, and at here also all the time during this time the distance is 10 miles. Between 0 to 10, between time equal to 3.3 to 3.8, what is the time is 0.5. So let's look at that, 3.3 to 3.8, that's here. What is the distance? Again, it's between 0 to 10 miles. The distance is something between 0 to 10 miles. After that, from 3.8 to 4.1. 3.8 to 4.1. The time that is passing is 0.3 hours. And the distance is 0 miles because it looks like during this time he was at home. And so on, you can find the answer to all the other questions, which are all similar to each other. Now, what is the farthest distance? It was 10 miles. That is basically the highest value of the function. This is the farthest distance that he had from home. And the next question says, how many times did he return home? That is 2 times, because once he return home here and the other time that he return home is here. These are the points that his distance from home is 0. Okay, we're done with most of the questions, the important one. And here's one more question which is interesting. Even if you don't have it in your homework, it's very helpful to know about that. So we want to match these following situations with these graphs. So let's see what is the first one. The cost of a painting a wall as a function of its square footage. So we know that the cost of a wall is going to go higher if the room is bigger and bigger. So here, or if the wall is bigger and bigger. So I'm going to choose this one, graph number 2, as the graph appropriate for part A, because it's growing with a constant rate. As the wall is bigger, the cost is going to be higher as well. Next one, the height of a ball drops from a 210-foot building as a function of time. So for this one, I'm going to choose number 3, because first of all, the initial height is 210. That's where the ball is going to be dropped. The y-axis represents the height, and the x-axis represents the time. So we know that when you drop a ball, always it has a projectile motion. So this is going to be the graph of the ball dropping from 210-foot building. Next one, the height of an animal as a function of time. So I would choose this one for part C, because as the animal is growing, the height is also going to be more and more, but at some point it's going to stop. The animal is going to stop growing. It's not going to grow forever. So for a few time, basically for maybe a few years, the animal is going to have higher and higher height, but then after a certain age, it's going to stop growing. So it's going to be constant value of the height. Next, demand for energy drink as a function of price. So we know that if an energy drink is very expensive, less people are going to buy that. But if it's less expensive, is cheaper, more people are going to buy this drink. So I would match it with this one. When the price is on the x-axis and the y-axis representing the demand for the drink. So when the price is low, the demand is high. When the price is getting more and more, the demand is going to get less. So this is the graph of D. And the last one, the height of a pentalion ball as a function of time. I would choose this one for that, because as a pendulum is moving, the height is going to go up, down, up, down, up, down. So the height will go lower and higher, lower and higher. So this is the graph of part E. I hope this was helpful for you. Have a great day.